All right, so I think this is recording. Let's take a look at these two equations. They are radical equations. We have in each one of these a square root. So similar to absolute value equations, we want to, in absolute value equations, we wanted to get the absolute value by itself. And here in radical equations, we want to get the radical by itself. So let's jump in on number one. And let's subtract 2 from both sides of this equation. So we have the square root of 2x minus 1 is equal to x minus 2. So we're trying to get the x by itself, but right now we really can't add 1 or divide by 2 to do that. On the left-hand side, we really need to get rid of this square root. So what we're going to do is square both sides of the equation. So if we square the left-hand side, we have to square the right-hand side. And when you do that, when you do something that's non-invertible, you're going to introduce the possibility of extraneous solutions. So we're going to have to check our answers to make sure it satisfies the original equation. All right, so on the left-hand side, if we square this, the radical goes away. And on the right-hand side, remember that exponents don't distribute. This is not x squared minus 2 squared. You have to think of this as x minus 2 times x minus 2. And whether you multiply that out in the form of a table or however you apply the distributive property, in some organized way, you want to multiply these two binomials. And what I get is x squared minus 4x plus 4. So this is a quadratic equation. Let's get it set equal to 0 and look and see if we can factor it. And if we can't factor it, we'll try to either complete the square or use the quadratic formula. So on the left-hand side, let's get this equal to 0. Let's subtract 2x from each side. Let's add 1 to each side. And it does look, when the leading coefficient is 1, it's much easier to factor. And two values that multiply together to give us a positive 5, but yet the middle term being negative 6 are negative 1 and negative 5. And so we have possible solutions of x equals 1 and x equals 5. But we're going to have to check those. We don't know yet if those are in our final answer. We just know that that's our list of possible solutions. All right. So let's take a look at the number 1. If we plug it in, what do we have? Well, let's return to the original equation. And 2 times x, if x is 1, 2 times 1 is 2, minus 1 plus 2. And the big question is that going to equal 1? So 2 minus 1 is 1, and the square root of 1 is 1. But 1 plus 2 is not equal to 1. So this does not check. It's extraneous. Let's take a look at x equals 5 and see if it satisfies the original equation or not. So on the left-hand side, we have the square root of 2 times x, which now is 2 times 5, which is 10, minus 1, plus 2. And the big question is that equal to, if we replace x with 5, is that equal to 5? Well, 10 minus 1 is 9. And the square root of 9 is 3. And 3 plus 2 does equal 5. So this one checks, and this is in our solution set. All right, so let's take a look at this next one. It's very similar to problem 1. We want to get the radical by itself, so we subtract 3 from both sides. We need to get rid of the radical, so we square both sides. Since that's, when you square both sides of this equation, you introduce the possibility of extraneous solutions. So we're going to have to make sure that we check our answer. On the left-hand side, this radical goes away, and we have x plus 3. Now on the right-hand side, exponents don't distribute. When you multiply this out, you'll get x squared minus 6x plus 9. So we're familiar with quadratic equations. You've solved them in every math class that you've had in high school. If we subtract 1x from each side, if we subtract 3 from each side, let's try to factor this before we jump in and use the quadratic formula or try to complete the square. Two numbers that multiply together to give us positive 6, but yet add together to give us negative 7 are x minus 1, x minus 6. So we get possible solutions of 1 and positive 6. But we know from our discussion about extraneous solutions, and that when you do something to both sides that's non-invertible, you introduce the possibility of extraneous solutions. So let's come in and check x equals 1. If we plug in 1 on the left-hand side, we've got 1 plus 3, and then plus 3. And the big question is that going to equal 1? Well, I don't think so, because 1 plus 3 is 4, and the square root of 4 is 2, and 2 plus 3 is definitely not 1. So this is extraneous. Well, what about the 6? If it's also extraneous, then we say there's no solution. So if x were to equal 6, on the left-hand side, instead of x plus 3, we've got 6 plus 3, then plus 3, and the big question is that equal to x, which is that equal to 6? Well, 6 plus 3 is 9, and the square root of 9 is 3, and 3 plus 3 does equal 6. So yes, that's in my solution set. All right, so don't be afraid to ask questions. Let me know if I've made any kind of silly mistake and I can edit the videos. I hope that helped, and I'll talk to you later. Bye.